Lesson 11.6. So our revision for the end of year exam will start by 11.6, which is talking about two-dimensional representation of three-dimensional figures. This is part 1. In this lesson, we are going to actually study the orthographic drawing given a solid. So let's answer these questions. Question 1. Make an orthographic drawing of the figure shown. As you see here, this is a 3D figure, and we have here many choices. We are going to find out which one is the most accurate one. If you look here, the easiest part is to look from the front. And from the front, you can see that it is on the same plane, three blocks, and the third block is coming, the fourth block, I mean, is coming up here. And no blocks are in or out. So you are going to draw them either this way or this way. What is the difference between the two presentations? There is a line here, as you see here, a red line here. What is the meaning of this line? This line means that not all the blocks are located in the same plane. There is a block either in or out. And here, fortunately, none of the blocks from the front point of view going in or outside. So that means we are not going to choose this. The most suitable answer is the D, from only the front view. Let's check the top view. The top view here matches with what he's saying here, because if you look from far up, you are going to see that all these blocks coming up, and it will look like that. This line is that. This line is this line where it shows the difference of planes. And you can check also the right view and the left view. The right view and the left view are usually symmetric. They are a reflection of each other. Always we can guarantee this. Okay, let's see now this exercise. Just have a look. Take a minute. What do you observe? Look at the front is the easiest way to check. If you look at the front side, you can visualize that the blocks looks like that, two blocks here where they are pushed a little bit inside, and there are two blocks here. So totally it will be 3. The most suitable answer is either this or that for the front view. While here there is a line that shows that the blocks are not all of them in the same plane. So this is the most appropriate answer. In this figure, we want to check only the back side, the back view. Imagine, what is the back side here? Is there any ladder? Is there any step in the back side? I don't think so. So the most suitable answer is D. Let's observe the front, the side, this one. What do you think the answer is if you observe from this side? From the side point of view, the most appropriate answer will be A. Okay, let's look at the front. Which one is the 2D presentation orthographic if you look from that side? Is it C or B? I think it is C, because the blocks here are thin little bit. And don't forget that if C will be the answer, then you should put red lines here to show that they are not all in the same plane. طيب, the top will be B. Also, don't forget that if you choose that, this is the representation with red lines. Just need to have an idea about what is happening. Now, let's see question 4. Question 4 is, which figure represents the top view of the solid? In the figures, gray segments indicate breaks, which we're talking about the red lines here. Okay, let's check here. Have a look here. Which one is the best answer? I can say that B is the best answer, but not fully correct answer, because if you look here, these blocks will go up. This also will go up. This will stay up. So the most, the best, I mean, presentation will be B. And actually, there should be another line here. This gray line, yani, which is like the red line, should be there. They missed one of the lines, but this is the best answer for the top view. Now, moving to the second part of this lesson, which is talking about the surface area. Identify the solid represented by the given net and find its surface area. What is the net? Net is the unfolded way of the 3D shape. Yani you are imagining that you are unfolding the solid, which can be prism, which can be cylinder, which can be cone. Any 3D shape can have a net when you open it, when you unfold it. Sometimes it is better to find the surface area when you open the shape, because you are going to divide the area into parts and find the area of each part. For example, for this question, identify the solid represented. What do you notice here? We notice that we have two congruent bases. Each of them is a triangle. And we have also here faces. Each of them is a rectangle. When you have two congruent bases parallel to each other, that means the 3D or the solid represent a prism. And we usually name the prism by the base, the name of the base. Since the base here is a triangle and this is a prism, so this is called triangular prism. Triangular prism. So what is the surface area of the triangular prism? In any prism, by the way, the faces will be always rectangles. So you have here two options. Either you can find the area of this triangle, the area of the other triangle, which is exactly the same. So you will find the area of one of the triangle multiplied by 2 and find the total area here of the rectangle and then add them together. This is one approach. Other approach is using the formula of the surface area of the prism. Surface area of the prism is pH plus 2 capital B. You should know what does each parameter means. P is the perimeter of the base. Now, this is our base. Our base is a triangle, and fortunately, it's an equilateral triangle. But they missed to write this side, but this is 5 and this is 5. They should put here 5. So if this is 5 and this is 5 and this side is also 5, the perimeter is the sum of all the sides. So our perimeter is 5 plus 5 plus 5, which is 15 centimeters. Okay, great. Now let's go to the h. H is the height of the prism itself. And the height usually separates the bases. In our case, it's very obvious this is 12. And you can imagine that this is our shape. So the height is the 12, which is separating two bases, actually. Great. Now, let's move to B. What is B? B is the area of the base. The area of the base. What is the area of the base? Our base is a triangle. How can I find the area of this triangle? The area of a triangle in general is half base by the height of the triangle. Our height of the triangle here is not here, so I will draw to imagine this is my height of the triangle. It's not the height of the prism. The height of this triangle can be found using Pythagorean. So I'll take this side, this part I mean. This part only is 2.5, and this is the hypotenuse. So our missing part is the h. The Pythagorean theorem states that the hypotenuse square is equal to one of the legs square plus the other leg square. Let's find it. So 5 square is equal to 2.5 square plus the unknown leg is h, so h square. That means 25 is equal to 6.25 plus h square. H square is equal to 18.75, and h is the square root of 18.75, which is approximately 4.3 centimeters. And this is 25 minus 6.25 for those who forget how to solve equation. All this is only to find the value of the h so that we can find the b. So our b, capital B, which is the area of the triangle, is equal to half times the base of the triangle totally, which is 5, times the height that we just found, which is 4.3. And this is approximately 10.75 centimeter square. Now everything is clear to us, and we will put everything in the general formula. So P is 15 times H, which is 12, plus twice the basis, which is 10.75. Totally, it is about 201.5 centimeter square. This is the surface area. Some students may like to find the area of the triangle itself, which we found already, which is equal to 10.75. We will take this approach. So this area is 10.75. This area is 10.75, and we need to find this big area of the big rectangle. You can divide the rectangles into 3 rectangles, or you can simply find out all the dimensions. So this is 5, this is 5, this is 5. So totally it's 15. Area of the rectangle is length by width times the width, which is 12. So 15 times 12, which is 180. And now total area will be 2 triangles, yani 2 times the area of 1 triangle, plus the area of the big rectangle, including the 3 of them. So multiply 10.75 by 2 and find the answer. It will be adding 180, it will be 201.5 centimeters square. So in both cases, you need to find, using Pythagorean theorem, the missing height of the base. Okay, great. Let's move to the other net. And this is very clear that we have 2 bases. Each one of them is a circle. And the lateral face, يعني الجانبي, is a rectangle, which is exactly looking like cylinder. Cylinder, area up, circle up, circle down, exactly copy paste of the first one. And this is the cylinder. This is 5, which is the diameter of the cylinder. This is the 9 centimeter, which is the height of the cylinder. Actually, if you want to find, if you open, this is a short cylinder. Actually, it should be shorter than this. Yani this doesn't look like this. It is a short cylinder. It's like that. Okay. Now, actually, if you want to find the length of rectangle, actually, you should imagine that you are opening this cylinder and it will be the circumference of the circle. So I don't like this. I like to use the original formula of the cylinder. So the surface area of the cylinder is 2 pi RH plus 2 pi R square. Let's do it one by one. Surface area is 2. I will leave pi this time. What is R? R is the radius, and the radius usually is the diameter by 2. Our diameter here is 5, so our R is 5 over 2, which is 2.5 centimeters. So I will use 2.5. H is the height of the cylinder that separates the 2 circles, which is in our case 9, plus 2 pi again. 2.5 square is the radius square. Using the calculator, I will do it one by one and leave the pi this time. I will not replace the pi now. I will answer in terms of pi and then replace. So I will multiply 2 times 2.5, which is 5 times 9, 45. So this is 45 pi plus 2 times 2.5 square. 2.5 square is 6.25 times 2, which is 12.5. So this is 12.5 pi. Adding 12.5 plus 45, it gives us 57.5 pi centimeter square. Now you can replace if you like. Why I'm leaving the answer in terms of pi? Because sometimes the answer should be rounded actually to the nearest tenth, and you should find it in decimal way. If you multiply this by 3.14, it will give us 180.55 centimeter square. That's it. And here we go. We have here to identify the solid that is identified by this net. In the net here opened, as you see, it's very clear that each part is a square because all the sides, are congruent. This is 18 by 18. This is 18 by 18. And that means the original shape was a cube. This is the original shape, if you remember. The easiest part in the cube is that all the faces are congruent. So if you find the area of one of the faces and then multiply it by 6, you will find the total area, which is the surface area. So area of one side of one face is the area of the square, which has length 18 by 18. So the area is 18 square, 18 times 18. 18 times 18 is 324 centimeter square. Since we have a cube, means 6 faces, so the total surface area is 6 times 324, which is 1944 centimeter square. With that, we are going to stop here for this part. See you in the next part. Thank you so much. نراكم بخير. إلى اللقاء في الجزء الثاني.